All right, now let's look at the first case. The rock is gone, completely fragmented, and the fragments dispersed at relatively high velocity. In the second rock, which is here, we're just at the threshold of catastrophic disruption. Most of the rock is still here, but pieces are scattered about. If this had been the satellite, the pieces would just barely have separated, and the gravitation of the satellite would have brought them back together. Now we go to a satellite that's a little bit bigger for the same size crater, and we see that we formed a crater, in fact, and the rock was partly cracked, which we can see here, but pretty much it held together. And then we go to still a bigger object, and the satellite is now intact, and what we see is just the crater. And otherwise, the satellite is not damaged.
Mimas was barely large enough to survive. The next moon, Enceladus, is almost the same size, yet it looks very different. Part of Enceladus is cratered and part is smooth, with a few large cracks running over the surface. There are no large impact craters. The surface of Enceladus is a puzzle. As this animation shows, Enceladus, like the rest of the solar system, was made by a prolonged comet and meteorite bombardment some 4.5 billion years ago. After the bombardment stopped, some unknown process caused parts of Enceladus to be resurfaced from the inside, making the smooth plains. And later on, a much less intense bombardment took place, which lightly cratered the entire moon, including the plains. The resurfacing probably happened several times. It explains the appearance of Enceladus, but it doesn't provide any reason why the resurfacing happened in the first place. Enceladus, which is made of almost pure ice, is frozen solid and is an unlikely candidate for any sort of volcanic activity. In fact, this place wasn't understood at all until much later in the mission, when the spacecraft encountered Uranus's bizarre moon, Miranda, which is its almost exact twin. Enceladus, which is only barely spherical, is on the borderline between round and irregularly shaped objects. Moving outwards from Saturn, the moons get larger. This is Tethys, which is large enough to be round. Dione is almost the same size, about 700 miles across, and is covered with unexplained wispy markings. Rhea is bigger still, about 1,000 miles across. All these bodies are smaller than the critical size needed for the stable existence of an atmosphere. Titan, Saturn's largest moon, does have enough gravity to possess one. Titan had long been a favorite candidate for extraterrestrial life. But the surface turned out to be completely hidden from view by a thick layer of orange smog. Fortunately, the spacecraft was equipped with an infrared instrument capable of looking through it.
This funny wiggly line is just loaded with information. We start at this end with a rather smooth part of the spectrum. We come into these interesting features here, ending up here with methane. So this confirms what we've already known, that methane is in the atmosphere. Down here we find ethane and acetylene, and this peak is very exciting. This is hydrogen cyanide, which hadn't been discovered before. It's exciting because hydrogen cyanide is a molecule that played a very important role in getting life started on the Earth. You can polymerize it to make adenine, which is one of the bases in DNA, the famous double helix, which gets us all going. And you can make amino acids if water is present, which was true on the Earth but not on Titan. And so I should make it clear that we're not saying that because we have found HCN in Titan's spectrum that we think life is beginning on Titan, but we do think that some of the chemistry that happened on the Earth before life began is probably happening on Titan today, And if we can study it in more detail, we can learn something about pre-life chemistry on the Earth.
Titan has an atmosphere made mostly of the gas methane, which is a useful fuel on our own planet. On Titan, the methane is being polymerized into the building blocks of primitive life. At present, this place is too cold for living things themselves to evolve. But in about 5 billion years' time, the sun will run out of hydrogen fuel and will expand to become a red giant. The Earth will be engulfed and destroyed. Titan, further out, will warm up and come to life. Regrettably, the precious warmth will last only a brief few million years before the sun shrinks back and becomes a white dwarf. Then all life in the solar system will come to an end. Beyond Titan, Voyager 2 took a distant look at Iapetus, one of Saturn's outermost moons. Iapetus was known to be half white, half black. On closer inspection, it turned out to be partially surfaced with black deposits like tar. Iapetus is an important signpost in the solar system. Voyager was moving into a zone where planets and moons begin to be made of quite different stuff. At Saturn, the trajectories of the two spacecraft diverged. Only Voyager 2 went on towards Uranus and Neptune.
It's almost a sacred color, yellow. This is a Kino symbol.
It is the power of the people that is manifesting itself now. So I am really counting on this landslide to offset any cheating that Marcos intends to do.
Uranus is 4 times the diameter of the Earth and orbits in a zone of perpetual twilight, 2 billion miles from the Sun. The planet, its rings, even its poetically named moons and their orbits are tipped over on their sides. Before the spacecraft arrived, nothing was known about why this was so. This giant planet and its coal-black moons were a complete enigma. The planet itself is probably made mostly of water, but Voyager saw no ocean surface, only a high featureless layer of blue haze. Uranus has 9 narrow rings. They're made of billions of independently orbiting moonlets. The ring boulders themselves are made of darkened ice, like dirty snowballs. As this animation shows, one of the rings, the gamma ring, is slowly bouncing in and out. When the solar system formed, the planets and moons out here condensed from different materials from the ones further in. Ammonia and methane seem to be mixed in with the ice in these twilit regions, which changes its properties. In the event, the darkened moons of Uranus provided the key to how the whole planet might have been tipped over. This is the magnetosphere of Uranus, the structure formed by the interaction of the planet's magnetic field with the wind of nuclear radiation from the Sun. In Uranus's case, partly because the planet is tipped over, this magnetosphere is very changeable. As a result, the surfaces of the moons in this environment are periodically bathed in nuclear radiation. This turns methane black. So the moons are darkened, like Oberon, the outermost of them.
The type of thing that we're looking for in a picture like this is evidence for what the structure of the planet is like, what caused it to be like this. And what we see are craters which have bright rays running out from them across a darker surface, and then rather darker areas in the center of craters. And what type of thing could create that? One of the simplest models that we have, and probably a correct one for this moon, is that it results from a layered structure. We have dirty, very rock-rich material deep within the planet, and then a cleaner ice layer outside that, and then on top of that, a dirty debris layer, if you will. And so what we're seeing over most of the moon's surface is this dirty debris layer, and when a large crater punches through that, it spreads brighter ice out over the surface that creates the bright rays.